Hey, good morning. This is going to be our first lesson for Algebra 1. This course will probably be just a little bit different than the previous one in that we can go a little bit slower and make sure that we have our concepts down. And so we're going to start, as you saw probably with the test at the midterm there from Algebra 1A from the first semester, that a lot of the first questions on the midterm were talking about naming and organizing real numbers. And so this is a little chart that I use when I teach this again to junior high kids, that I have a pyramid like this. And so my kids I ask them to draw this pyramid. They just draw 1, 2, 3, 4 boxes over here, and then one box over here. And after they get used to this pyramid, they don't even draw the boxes, they just put the right names in the boxes. And so here we go. In your notes here, these are your notes. So these are what we call guided notes on lesson 1. So if you're new to my class, these are your notes. This is your textbook, okay? And then every day you'll have a practice sheet that reinforces these concepts that we go over in class here today, okay? So on this first box here, what I'd like for you to do is write this name called natural numbers. Because at the very top, the very first thing you learned in elementary was these numbers. So these are natural numbers. And that is everything that was accounting numbers, like in first grade and kindergarten, that you said numbers like 1, 2, 34, all these numbers that you learned in first grade and kindergarten, okay? We're calling them natural numbers. Sorry. Then we said, hey, you know what? There's this other number, which you probably knew this one in kindergarten, first grade, and this is usually where most charts start, whole numbers. We're going to go with the next one. You're going to have to kind of write small in your notes here to get these up here. So these are my examples here, okay? 1, 2, 3, 34, anything that's a counting number to the right of 0. So whole numbers includes all of these numbers plus 0. 0 is thrown into the group. Okay. Then we have the next ones that when you got a little bit older, we had these things that were called integers. Now integers were these things that were called negative numbers, and so that'd be like negative 16, negative 28. Anything that was a negative number was added to the groups of these numbers here. Again, they're called integers, negative numbers. Okay. And then the last group on this side here is called rational numbers. I want to put numbers up here as well. You don't have to write this every time though, but these are all numbers obviously. So rational numbers is when you got into like 3rd, 4th, 5th grade, you started getting things like fractions and decimals like 1/3, which is the same as 0.333 as a repeating decimal. Okay, 1/3 is 2/4, which can be reduced down to 1/2, or a 0.5. Okay, so anything that is a fraction that's repeating or a fraction that's not repeating, like 0.5, is a rational number. So these notes down here, all fractions and decimals that have an end or a repeating pattern, these notes kind of go with this box right here to help you with that one, okay? Because over here, when we go to this box here, this guy here means repeated decimals, and it's going to fill up your whole calculator screen. And so over here, we have these weird ones, I call them weird, are irrational numbers. And irrational numbers are things that are decimals that have no repeating pattern and they never end. So anytime I see pi, which pi is 3.14 with lots and lots of digits after it, that's an irrational number. Now if you'll grab your calculator and just take the square root of 2, and I highly recommend you do this. If you don't have a calculator, because I know Mrs. Tilton kind of gave calculators but you need calculators to do your homework. So you need to get one of your own so that you know how to use it and you can use it to get your homework done. So when I put in square root of 2 on my calculator, I get square root of 2, but if I hit let's change that to a fraction button or a decimal button, I get 1.4142135562, and it goes on for a long time, fills up all my digits in my screen. And so square root of 2 is an irrational number. Okay? Now, very, very important how this works here with my pie system, or cake system I might kind of call it, is these numbers, they can only fall down into the next box. Okay? So, when they ask us what's all the categories a number can be, and I'll explain this here in a second, but the numbers can only fall down. They cannot jump across to this box over here. Okay, so if somebody said, okay, what's all the categories number 2 would fall into? I would say, well, it's a natural number, it's a whole number, it's an integer, and it's a rational number. It fits in all of these. But if I had the number -16 was my number, then I cannot say it's a natural number and a whole number, because the numbers can't go up. They can only fall down. So the number -16 would only be an integer and a rational number. That's it. Okay? Now, we missed one up here. It's called all numbers are real numbers. So there's a big box up here. And that real numbers includes everything, including irrational numbers. Okay? Forgot an L in there. And an A. There we go. Irrational numbers. All right, so let's go down now and look at this and use this pi here. If I said the number is 30, there's nothing I can do to 30. In other words, I can't reduce it. I can't do any more math. So 30, if I look up here, 30 is going to fall into this one. Oh, you know what? Let's make a key for this so we don't have to write all these words, okay? So let's call natural numbers n, since that's the first number in there, okay? Let's call whole numbers a W down here. So this is like a shortcut key. Let's call irrationals IA, so that stands for irrational, and let's put rational numbers as an R. Now this is where it's a little weird, because rational and irrational, rational is in both of these words. So over here I want to put IR, and that only stands for irrational numbers. Okay. Let's come up here and make a category for real numbers. Let's call that guy A, because all numbers are real numbers. Okay. So if you wanted to, you could say A on all of these right off the bat, because all numbers in our number system are real numbers. Now, as you get older, you'll get these things called imaginary numbers, but that's like when you get to be a junior or something like that. So we can kind of cheat a little bit. Nobody better miss this part. They're all real numbers, every single one. Okay. Now let's go back to our natural numbers. Our 30 here. 30 falls into this category up here called natural numbers. So now that we have a code, we can put it's an N, it's a W, it's an I, and it's an R. 30 goes into this box right away, and it falls into this one, then it falls into this one, and then it falls into this one. So this is the reason I like this stacking cake kind of method, is they can only fall down, they can never go up. So now if I come over here and look at -11, -11 has a negative, so it starts right here at integers. So after I have that it's a real number, I say it's an integer and it's a rational number. Hey, that spells the word error. Fractions. There's nothing I can do to this number. 4/7 can't be reduced. 5 4/7, it's a fraction. So when I look up here at my cake, fractions fall into this category called rational numbers. Well, it's already at the bottom of that cake. So it's just all real numbers, and it's a rational number. The only two things. Nothing's underneath this box. Okay? Now, square root of 21, sometimes you might take your calculator, because I'm not sure what the square root of 21 is. And so you got to know how to do square roots on your calculator. I want to do square root of 21. I want to make it into a decimal. Now, it looks to me like it fills up all my digits in my calculator. And so if it fills up, and I'm looking at all those digits, I have a 5, 8, 2, 5, 7, 5, 6, 9, 5. None of those are repeating. So this one is an IR, irrational number. There's no other numbers or boxes underneath this guy. So he's kind of over here all by himself. That's why I call him kind of the weird box. Okay. 0 starts right here at whole numbers. So I'm going to put after the A, I'm going to put whole numbers. I want to put irrational numbers and then rational numbers. And I like to say these out in my head, kind of out loud. Not out loud, but in my head, because then I know what the W stands for, the I stands for, and the R. And so you're kind of teaching your brain a little bit about these names of these boxes here, okay? Sometimes you have work to do. I got work to do. I know what the square root of 9 is. That's a 3. And I want to bring down that negative sign, okay? So that is really the answer now, where I'm going to start, what box it's going to start in. And I know that negative number starts up here with integers. Right there's a negative. Okay, so it's a -3. So after my real numbers, I'm going to start here with integers. Integers, and then it's also a rational number. Okay, integers, rational number. All right. 6/3 is a fraction that can be reduced. 3 goes into 6 2 times, and so that really equals 2. So after all real numbers, 2 starts up there in that box called natural numbers. So this baby's going to have a lot of names. It's a natural number. Then our next one is whole numbers. Pretty soon you'll know this pattern here. Whole numbers. Then we got integers, and then we got rational numbers. So that guy 2 is everything. He starts on the very top layer of the cake. Now anytime I see the symbol pi, I already know it's an irrational number. Okay, pi is one that's kind of like a given that it's an irrational number. So I'm going to put IR there. Here we have a repeating decimal. It's 0.3. That's what that sign there means, repeating 3s. And so repeating numbers falls into this category. Again, there's no box underneath this thing, so after all real numbers, we just have R there, rational. I don't know, 144 divided by -3. I know it's going to be a negative because that's a positive, and I know the square root of 144 is 12. So in my head I'm thinking, okay, that's really 12 over -3. And 12 divided by -3 is a -4. So that's the number that I'm going to start looking for my first box. And -4 starts right here with my integers. So after all real numbers, it's an integer. Then we go on down to rational numbers. There's a negative sign now, but I have a decimal here. So I can't start right up here at integers because these guys don't have decimals. And so even though it's a negative, it's a decimal, and it ends, because it's right there, 875, so it's just this guy right here. Okay, it's just A and an R on that one. Rational number. I don't care what the square root of 17 is, but if I have negatives or square root of 17 divided by square root of 17, any number divided by itself is just 1. Okay, so this whole thing here is really 1. So after all real numbers, I know this guy starts at the top, that he's a natural number, he's a whole number, he's an integer, and he's also a rational number. It's all of the boxes on the left-hand side up here in our notes. All right? So a lot of times, again, kids will draw this real quick on the edge of their paper somewhere. Okay? And then they can just use it to answer all these questions. All right, so let's do that real quick. All real numbers is everything. Okay? I'm going to put real numbers up here. Boy, that's pretty sloppy. I took 2 weeks off here. So this is real numbers. I want you to abbreviate that. And that's our A right there. Okay, so I'm going to put real numbers up here. All these numbers are real numbers. Okay, so really, I don't even count this as a group. But let's go over here. Let's go with natural numbers. Then we have whole numbers. Then we have integers. And then we have rational numbers. You have to remember this order of these guys. Okay. Over here, I have irrational. And these are those weird ones like pi, numbers that don't repeat but fill up the whole screen, decimals that don't repeat. I'm going to put decimals, no repeat. Okay. I even sometimes will do this, natural numbers to help me. That would be like counting numbers, 1, 2, 3. Whole numbers includes 0. Integers is negative numbers. And rational numbers are fractions and decimals. Now I can go and answer these guys, okay? So place the letter of each value in its location. So here's my letter A, it's a 7. 7 starts way up here at the top. So place the letter of each value in the location of the number system below. So 7 starts up here, so I want to put the letter A in that box because they said place the letter. So A starts there. But A is all of these guys, okay? So I'm not sure if they want me to put an A in everything in the real number system below. Interesting. Let's just know this. We all know that if A starts up here, it should go all the way down. We better put it down here in all these boxes. So let's put an A here, an A there, A, I'll put an A. I'm going to put the letter in all these because A is in all those boxes. I know 36 divided by 12 is 3, so this guy really equals negative 3. Negative numbers start down here with integers, so I'm going to put a B there. Okay, alright, so what I want to do now is I want to pause and then I want you to continue on and see if you can put these numbers in the right category. Now if you mess up, that's okay. We'll just fix it when you come back. Okay, so pause the video and then put the rest of these letters into the boxes that belong to this, and then put it in the box below it as well. Okay. Alright, let's see how you did. Did I do C? I didn't even do B yet. Yeah, I did. I did B. So C, square root of 36, everybody should know, is 6 times 6 is 36, so that really equals negative 6. So again, sometimes there's work to do. Negative 6 starts right here, so hopefully you have a C in that box and a C down here. Okay, pi, that's an easy one. He goes over here. 6.48, that's a decimal, and decimals start right here with rational numbers, and so he should go in this box and only that box, nothing's underneath him. Negative 2 starts right here with negative numbers, so I'm going to put F in that box right there. Now that's going to be a negative answer because the negative's out in front, but I have no idea what the square root of 10 is, so I'm going to put it in my calculator real quick and do the square root of 10. As soon as my calculator turns on here. And I see that it fills up all the digits in my calculator, and I see 16227766. Nothing's repeating, so it doesn't go on forever. So that means this guy is, which one are we on? G. He's an irrational number. So he goes over here. Okay, 0, he starts way up here. So H goes there. H goes here, H goes here. Again, they can only fall down, they can never go up. 1/6, I don't know if 1/6 is a repeating decimal or not. Ah, it is. Now my calculator says 1666666, and then the very last digit is a 7. So that means your calculator is rounding the very last digit. But I see all those 6's, and that means it's a repeating decimal. Okay. And so I is down here of decimals and repeating. So I goes right here. Okay, so kind of be careful. Here we go. I got a 0.7. He's a repeating decimal. So J goes down here. Hopefully you have a J there. And now square root of 4/81. Gotta know how to use your calculator. So I'm gonna do the square root button. On the black calculators, that's like the TI-30X, you have to hit second function and then square the x squared button. You'll see a little blue square root button above it. And so you gotta know how to use your calculator. So I'm gonna put in 4 divided by 81. And I think on this calculator you have to close the parentheses. Yeah. And I got a repeating decimal 0.22222. Now, if you have the TI-30XS, that's the one I like to use. I'm going to put in 4 over 81 divided by 81. Let's see, and that one also says 222. So he's a repeating decimal, and so the K goes right there. All right. So these are all the letters that you should have had on your paper. Okay. If not, fix it, and then use these notes to do your homework here tonight. Okay. Which expression does not name an integer? So this is, I hate these not names. So an integer is these guys up here, negative numbers. Well, I see a negative sign right there, so he's an integer. I'm looking for something that's not an integer. If I put 0 into my pi up here, well, 0 is right there, it starts there, but he falls down into the integer, so he's also an integer. Now 6 over 14, 6 divided by 14. I see it fills up my whole screen, and I don't see any repeating decimals, so I think that guy's an irrational number. I'm just going to check D over here. 12 divided by 6, well, that really equals 2, and 2 starts way up here at the very top and falls into all these categories, including integers. So letter B is the only one that is not an integer. Okay. Which expression represents an irrational number? Well, that previous problem, that was an irrational number because it filled up my whole screen and it wasn't anything repeating. Right here, I see a repeating decimal, so already I know that guy's a rational number. Okay. Now 2 divided by 3, if you don't know, is 0.66666, and when I do it on my calculator, see the last digit is the 7, so that means they rounded it for me. So he's a rational number. I'm going to put this here just so that we remember. We're looking for an irrational number. I have no idea what the square root of 75 is. I got 8.6625403.8, and it looks like it fills up my whole screen. So I'm thinking it might be this guy. I won't put an underline because I'm pretty sure that fills up my whole screen, which would be an irrational number if the decimals don't repeat. Now if I have a square root of 3 and minus the square root of 3, well, that would be like 3 minus 3. I mean, just square roots, they're the same thing. You can, or 2 minus 2, well, anything minus itself is always 0. So you had a little bit more math to do here. Even though it's a square root of 3, take away the square root of 3, leaves us with nothing. So that really, guy, is a 0, which on our pi up here, 0 starts with whole numbers, and he falls into this and falls into this. So he's a whole number, an integer, and a rational number. So now I'm sure letter B is the right answer for an irrational number. We go back to that not, and they capitalize that, or bold, make it bold, I'm sorry. Which number is not a whole number? So if you remember back to our pi, whole numbers is right here starting with 0. Okay, so if it's 0 or any negative number or any decimal or fraction, then we're on this side here. I'm looking for something that is not a whole number. Well, 8 starts way up here, and it falls into the whole number category. So it's a whole number. 0 already starts at the whole number, so he's a whole number. But now look, negative 10 starts down here. And he can only be an integer and a rational number. He can't go up. So negative 10 is not a whole number. I'll circle it for right now for sure. And I know 18 divided by 3 is really 6. And 6 starts way up here at the very top. So he falls into that whole number category. Okay. Which of the following is a true statement? Negative 9 is a whole number. Looking back up here at your notes. Negative 9 starts down here underneath the whole number, and again, they can only go down, can't go up. So negative 9 is not a whole number. So that's not true. We're looking for a true statement. not true. You don't have to write that. 0 is a natural number. Looking up there, 0 is a whole number. Natural numbers is above it, so that's not true. I'll put NT, not true. 25 is an irrational number. Now remember, irrational, the IR is that makes it a weird one. That means, but I know the square root of 25 is 5. 5 times 5 is 25, and that's what square root means. What number times itself will give you that number that's underneath. Well, that's not an irrational number because that guy starts way up there at the natural number category. So that's not true. So I'm thinking it might be this guy. 2/3 is a rational number. Well, the 2/3 is a fraction, and so it starts right here in the fraction category. Even if it's a repeating, which 2/3, 2 divided by 3 is going to give you 0.666666. So that is a true statement. Okay, and we got a couple more here. Which of the following statements is false? So I'm looking for something that's not true. All real numbers are rational numbers. So if I come up here to my cake, all real numbers are rational numbers. Well, that's true because all real numbers is everything. That's true. I'm looking for something that's not true. So that guy's true. All natural numbers are integers. Where does natural numbers start? This box. So 2, let's just take that. It falls into the whole numbers, it falls into integers, it falls into rational. So let's see what it says again. 0, all natural numbers are integers. Well, that's true because natural numbers is this category up here, and if all of them will fall down into the integer box. That guy's true. We're looking for somebody false again. Every integer is a rational number, so we got to see where integer starts. Every integer, so all these numbers, don't they all fall down into rational? So that guy's true. Oh, looks like D. Every whole number is a real number. Whole numbers. Here's a whole number. Every whole number is a real number. That one's true, so we boo-booed somewhere because all numbers are real numbers. That's the easy one that nobody better miss. All real numbers are rational numbers. Oh, wait, look at A. Even though they said all real numbers, so like 2 is a real number, but 2 is not a rational number. I skipped that one. I read it backwards. All real numbers are rational numbers. All real numbers, so 2 is a real number, but it's not a rational number. So I'm thinking A is false. That one kind of tricked me there, because now down here every whole number is a real number. Well, that's true. All natural numbers are integers. Man, it really helps to have that box. Natural numbers are integers. Yep, they all fall down into the box. Every integer is a rational number. That's true, and all integers fall to the box below. All real numbers are integers. Yeah, I'm thinking the first one because like 0 is a whole number, but it's Oh, you know what? Down here, if I went this way, 0.75 is a rational number. It's also a real number, but it's not an integer. Yeah, now I'm sure it's A. I'm sure it's A. All right. Yeah, it's very confusing. And a lot of kids would say, well, who's going to ask you this in the real world? Nobody's going to really ask you this. Never in my life has somebody said, hey, you know what? You went to the store and you bought $12.35. What kind of a number is that? So, but it's something that we got to learn. All right. Give an example of a number that is a whole number, but not a natural number. A whole number. Well, whole number starts at these guys. Well, the only number that's a whole number and not a natural number is 0. Because I went down to negative 16. Well, negative 16 is not a whole number, so there's only one answer for that guy. 0. Give an example of a real number that is not a rational number. So a real number, well, all numbers are real numbers, so really I'm looking for anything that's over here. I'm looking for really an irrational number. So pi would be one, square root of 2 is one. That one comes up all the time. Most kids use pi. We can use square root of 2. I'm trying to think of another one. I think square root of 3 maybe is one. Yeah, square root of 3 is one. Square root of 4 isn't one, because square root of 4 is 2. Okay, so you got to kind of be careful with these. There's some that will just keep coming up all the time that you'll just start to memorize. And our last one, give me an example of a rational number that is not an integer. Well, that's easy. Just pick anything from the box in the bottom here. Any fraction is not an integer. Any decimal is not an integer. Okay, so any fraction that you have or any decimal that you have, that would be okay. So you can say a half, you could say 0.5, you could say 0.75. Now what you can't do is do 4 halves. Even though that's a fraction, that guy really equals 2. And 2 would start way up there at the very top, called natural numbers. Okay, so you just can't make any fraction up, because that guy would really equal 2. More work there. All right, so there you go. First lesson today. So if for some reason you were on vacation or something and you missed a lesson, this should help you, I hope. All right, now you should be getting a practice paper, and practice papers are always due the next day. Okay? All right, thanks for watching.